So today we're going to learn about uniform distributions. But first, as a warm-up, we're going to play a game called That's the Way We Roll. And in this game, you win the number that appears on the dice in dollars. So for example, if you roll a 4, you would win $4. If you roll a 5, you'd win $5, and so on. Okay. So if you have a dice somewhere in your house, I want you to get it, and I want you to play the game 20 times. If you don't have a dice in your house somewhere, then you can always use a virtual dice simulator online. So pause the video, play it 20 times, and record what you got. After you've done recording it, I want you to calculate the average that you won over the 20 games. So you can add up everything that you won and divide it by 20. Usually at this point, I would have everybody in the class come up and put what they won on the board so that we could find a class average. So I'm actually going to use my last year's data, which is right here. So this was from my class last year. There was 22 kids in it. We added up all 22 scores, divided it by 22, and then we got an average of 6.67. So what we've really done there is we've kind of calculated an experimental expected value. So that was our experimental expected value. What would be the actual expected value? So we're going to calculate that using what we learned last lesson. Okay, so remember to find the expected value. That's that E of x equals the sum of all the x's times the probability of each event occurring. Okay, so we need a probability distribution to start with. X is all the outcomes, so in this case we could have won $1, $2, $3, all the way down to $6. Okay? And since this is rolling a dice, right, to get a $1 we have to roll a 1. The probability of rolling a dice is 1/6 for everything. So now we can calculate the expected value. Okay, so for our expected value, we're going to take our x, so in this case 1, and we're going to multiply it by the probability. And then we're going to go to the next line, take the 2, multiply it by the probability. And we're going to keep doing that all the way down. And if we added this all up, we would get 21 out of 6, which is 3.5. So what that means is the expected value for this game is $3.50. So on average, if you kept playing this game and playing this game and playing this game and calculated the average of your winnings, eventually it would approach $3.50 or equal $3.50 in this case. Okay. And what else I want you to notice here is that the probabilities here are all 1/6. Okay? All the probabilities are the same. Some might even call them uniform. So we're going to do this again for a new game. This time it's a spinner game. There is a cost to play, it's €5. And if you land on blue, you get €8. If you land on yellow, you get €2. And they're asking us, is this a fair game? Justify your answer. So take a minute and try and do this question, and then replay the video to get the answer to it. So if we are going to figure out if this is a fair game, we need to find the expected value. Okay, so once again, to find the expected value, we need to do a probability distribution. Okay, so the outcomes, €2 and €8, and the probability of each is a half, because there's an equal chance of landing on each side of the spinner. So for the payout, our expected value here is going to be 2 times a half, right? X times P of x, plus 8 times a half. Once again, X times P of x. And that would get us a 1 plus a 4, so that would get us €5. So the expected payout is €5. And what that means is that overall, the expected value is going to be a payout of $5 or €5 minus the €5 it takes to play. So our overall expected value is 0. And since e of x equals 0, this is a fair game. Because whenever the expected value is 0, that means we have a fair game. So once again, you'll notice that this example happens to have an equal probability of every outcome. Once again, it's uniform. And if we were to graph this probability distribution, we would also see that it is uniform. So if we put our x down here, the 2 euros and 8 euros, and if we put our probability at the side, this would be a half. Okay. When we draw our bars, the bars will all be of equal height because they all have the exact same probability. This is actually what we call a uniform distribution. And we can recognize a uniform distribution when the probability is evenly split amongst all the possibilities. So often you want to find the probability that a variable falls in a particular range of values. This kind of probability can be determined from the area under a distribution curve. That might seem complicated, but we'll do an example to show you how to figure that out. So here's our example for probabilities in a uniform distribution. So we are driving between Toronto and North Bay, and the driving time is found to range evenly between 195 minutes and 240 minutes. Okay, so that means the likelihood of somebody arriving within that time frame is the same for every single possible time. What is the probability that the drive will take less than 210 minutes? So, the first thing we need to be able to do is recognize that this is a uniform distribution. And the word that tells us that this is uniform is the word evenly. Okay? So because the probability is evenly spread out, that means that we're going to have a uniform distribution. So, the distribution ranges from 195 to 240. So I'm going to start here. This will be 195. And this will be 240. Okay. And there is an equal probability across all of these times. So we know that whatever this probability is that's right here, it's going to be the same for every single time. So the way that we're actually going to find what this probability is we're going to figure out how many minutes there are between 195 and 240. So if we do that subtraction, 240 minus 195, we get 45. So the probability of arriving in any of these 45 minutes is going to be 1 out of 45. So that is a sketch of our probability distribution. So there's our p of x, and down here is our x, which is really, in this case, time. Now we need to actually answer the question that they asked us. So it says, what is the probability that the drive will take less than 210 minutes? Okay, so let's start by drawing in the line that represents 210 minutes. Okay, so I drew it roughly about there. And we want to figure out what's the probability that it takes less than 210 minutes. So that's the same as saying, what's the probability that it takes between 195 and 210 minutes? Okay, so to calculate this, we're actually going to calculate the area of this rectangle. Okay, so we already know that the height of the rectangle is 1 over 45, because that's what it has on our y-axis there. And then to find the width of this rectangle, we're just going to do 210 minus 195, which is 15. So to find the probability that x is less than 210, we're going to find the area. So we're going to do length times width. So our length is 15, and our width is 1 out of 45. So That would give us a 1/3 of the time the drive will take less than 210 minutes. Okay. So whenever you're trying to find the probability of a range happening and you have a uniform distribution, you're always going to calculate the area under the curve, which is nice here because that's going to be a rectangle, and we can fairly easily calculate the area of a rectangle. We'll see later in the course when we do something called normal distribution curves that it becomes a little bit harder for us, well, it becomes a lot harder for us to calculate it directly, and so we actually have to look up tables to find the probability, the area under the curve. So the last thing that we're going to do today is we're going to talk about types of distributions. So the first group is unimodal, which means one mode, and really one bump, sort of, if you want to think of it that way. So our first type is called negatively skewed. And negatively skewed is when you're going to start with a tail, and the bump is actually pushed over towards the more positive side. So it has this longer tail, this negative skew. Okay. Positively skewed is actually the opposite. You're going to have sort of your bump happen first, and then the tail is going towards the positive side. And normal is when the bump is nice in the middle. We also call this a bell curve. So if I can draw it perfectly here, it's good enough. So you have that bump, that mode, that highest point right in the middle. And these are all unimodal. They have one highest point. Bimodal is when you have more than one highest point, in fact, two highest points. So something that's bimodal would look like this, where there's these two higher points. Okay. If our distribution is uniform, so that's a couple examples of what we saw today, it should be a straight line, because the probability at every single point that there is should be the exact same. Okay, and then exponential, if something is exponential, then the distribution would look like an exponential curve. Okay. So that is what we had to study today. So you guys can get started on the homework that is posted below this lesson. Have a good day, guys.